So this is the GATE 2012 question number 3. It states that the space-time dependence of the electric field of a linearly polarized light in free space is given by x E naught cos omega t minus kz. Now this is actually what I think is a printing mistake, because as I have already told and as the physical concept is there, that E naught is nothing but a constant vector. So constant vector cannot have this x, therefore it has to be x cap. That is, in the x direction, this is the constant magnitude E naught. So E naught x cap cos omega t minus kz. Then this is the electromagnetic wave in terms of the electric field. So all these things are written now, E naught, omega k, what are those angular frequency wave vector respectively. Now the time average electrical energy density associated with the electric field is what we need to find out. So first we will see what is the energy density, what is the formula of energy density, and from there we will do the time averaging. See, time averaging and phase averaging are same, so we will just put the time averaging as the phase averaging and do the other things. So now if we go to the solution here, so this is the electric field which is given, E naught x cap cos omega t minus kz free space. Now to find the time averaged energy density associated with the electric field, we know that the energy density associated with the electric field is half epsilon naught E square. So from where does it arrive? It is coming from this capacitor. If you consider a capacitor, from here actually this energy actually is half CV square, and C is actually epsilon naught A by D. So from here it is coming, so this is V square, and this can be written as E square D square. So we can write it epsilon naught A. So if this is the D and this is the area of cross section of this particular capacitor plate is say A, okay, this is the electric field, and A by D, and this becomes V square is actually written as electric field square into D square, because that is the definition of the potential difference or the V, the voltage. Now this becomes, therefore D and D cancels out, and this A into D is actually the volume. Therefore this is the energy. So energy divided by AD, if you do, this becomes the energy density, and that becomes equal to half epsilon naught E square. This is from where we are getting. So this is half epsilon naught E square. Epsilon naught I have taken, not epsilon, because permittivity in the free space, because it is given in the question that it is a free space. So the energy density becomes half epsilon naught E square. Now E square can be written as given in the question, E naught x cap cos omega t minus kz. So square it. So it becomes E naught square cos square omega t minus kz. Now we have already found out the energy density, and now we need to find out the time average. So time average definition is this, and this definition exactly holds for the phase average. So time average and phase averaging gives the same value. So therefore we will do, because as we can see that it has omega t minus kz, it is a complete phase. So it's better to do the phase averaging, because time averaging and phase averaging are nothing but the same. So if you do this, we have just replaced it by 1 by 2 pi. Instead of t, it will be 1 by 2 pi. In fact, omega t minus kz, if you take it as phi, then this omega dt becomes equal to d phi, and that way also you can change it to the phase averaging. So it becomes 0 to 2 pi cos square phi d phi. Although we all know that this phase averaging or time averaging of this cos square component is actually half. Whether sine square or cos square, it becomes half. If it is sine or cos, it will be 0. So this is known to us, but further if we can solve, we better to do it in the phase average form, because this will help or easy for integrating. Okay, so it's 1 by 2 pi, 0 to 2 pi, again 1 plus cos 2 phi by 2 d phi, and this term will be 0. This term only remains, so becomes half. Therefore UE phase averaging becomes half epsilon naught E naught square into half. So 1 by 4 epsilon naught E naught square will be the, that is option A is the answer. So we need to remember from there, no need to do all those calculations. Sine square, whatever term is there, or cos square, whatever term is there, if you have to phase average or time average, it will be always be equal to half. If it is sine of something or cos of something, if you're doing phase average or time average, this will be always 0. So these things needs to be remembered in order to solve the question fast. So this becomes A becomes the correct option 1 by 4 epsilon naught E naught square. So let's see the question again. So yes, 1 by 4 epsilon naught E naught square is the correct option for this question number 3. Thank you.